All right, this is the Edgenuity solving by substitution. I personally don't think that we should restrict it only by either elimination, the previous lesson that we learned, or the substitution, this current lesson. I personally think that you have to really play by the situation. Sometimes it's a lot easier to use substitution, and other times that you're gonna be better off using elimination. So now let's just respect this lesson. It said that we have to use substitution, so I'm going to use mostly substitution here. Okay. All right. So first thing you want to do is you want to solve this linear system using substitution. So you know that y is equal to 3x minus 5. Also, y equals to 2x minus 6. Okay. You can sub in this expression because that's basically y into the y in the second equation. Okay, so what's going to happen is it's going to look like this: 3x minus 5 equals to 2x minus 6. Okay, you're going to go ahead and solve it. We're going to subtract 2x on both sides, and I'm going to add 5 on both sides. So I'm going to get x equals to -1. Okay, that's the only one you get for the x equals -1. So I don't need to go ahead and solve for the y. All right, so you're gonna solve the first equation for y. So which means that the first equation you need to isolate y. So 6x minus 2y equals to 10. What you're gonna do first is you're going to subtract 6x on both sides because we're trying to isolate y, right? We got 2y equals to -6x plus 10, and I can just divide it by -2 on all three terms. See what's going to happen. I got y equals to 3x minus 5. Okay, so in the blank, you're going to put 3 in there. Erase this. You need a bigger eraser. Oh, no. Okay, erase this. All right, so which choice? So over here, which choice shows the resulting substituting 3x minus 5, plug it into the second equation for y. Okay, you gotta have to plug that in because that's equal to y. So plug it into the second equation y. So that would be 2x plus 3, and I'm plugging 3x minus 5 in there, which equals to 51. Okay, so we want to choose the second one right here. Okay, the second one right here. All right, so erase this. I constantly need some space. All right, so you want to solve the equation. So you got 2x plus 3. Damn, did I just erase that? I shouldn't do that because I'm just rewriting it. Okay, so go ahead. You're just gonna solve for x. So it's distributing the 3. So 2x plus 9x minus 15 equals to 51. So that's 11x. You combine the 2x and 9x, and you're gonna add 15 on both sides because I want to get rid of the constant on the left hand side. So that's going to be 66. So x equals to 6. Put 6 in there. So after you complete the finding the x, you're going to plug in. That's what you're going to do. You're going to plug in 6 into one of the x's and go ahead and solve for y. Not going to do that. Just going to give you the answer. You can go ahead and do it yourself. You're going to get 6 comma 13. Move on. So this one, what is the best first step in solving the system using substitution? I hate when they say what's the best. What is the best? Whatever they think it's the best might not be the best. So I have to tell you the way they're trying to think is what is the best, which variable should we isolate in here? Okay, the best one is not the 5x, not the 2y, not the 4y. It's actually the 2x. You want to try to isolate x from 2x. Okay, so I'm going to show you how. I'm going to write that here. So 2x plus 4y equals to 12. So I'm going to subtract 4y on both sides. So I have 2x equals to negative 4y plus 12. Okay, now it comes into play when I have to divide it by 2 on all three terms. And I will get x equals to negative 2y plus 6. Okay, the reason why they say this is the best is because when you're isolating the variable by dividing the 2 in this case, you're not going to get any fraction. So there's no fraction. Okay, they call it the best is because of that. So you want to pick this one, solve for x in the second equation. If you pick any other three variables, the 5x and 2y and the 4y, you are going to get fractions in one of the terms. That's why it's not the best. But sometimes, if you like fractions, you might think that it's okay to go with the fraction route. All right, so let me erase that. All right, so you're gonna have to go ahead and solve it. So what you're gonna do is just go ahead and solve it, right? I'm actually gonna try to use a different method to solve this. Okay, I told you guys the freedom of solving equations. You don't always have to use the substitution. Okay, now let's do this elimination. So let me multiply the 2 on the first equation. So that's going to be 10x minus 4y equals to 30. Okay, I'm going to rewrite the second equation right there. So 2x plus 4y equals to 12. Okay, see, we learned this one, right? All you need to do is add up the two equations. Okay, so you're going to cancel out the y's. So you got 12x equals to 42. And you're going to divide it by 12 on both sides. You're going to get x equals to 42 over 12. You can simplify that dividing by 6 on both numbers, 42 and 12, sorry. So that's going to be 7 over 2. The only one with the 7 over 2 right there. Move on. So let's look at the substitution. So you don't always have to use substitution. So this is what I'm going to do. You just have to pick the better one of two. Okay? Look at this. How do you get to 4x from 4x to negative 12x? You have to multiply the first equation by negative 3. Okay, so what's going to happen is you're going to see that this is negative 12x plus 3y equals to negative 21. Okay? Wait a minute. Did you see this? Let me rearrange this, the red equation. So I can rearrange it by putting the 3y in the front. So 3y minus 12x is equal to negative 21. Is that the same as the second equation? Which means that two lines are going to overlap with each other. You're going to get a lot of solutions. So you're going to pick the infinite many solution. So that's it for the assignment part. Now let's get down to the quiz business. All right, so which equation shows the result of substituting? Okay, so you have to substitute, and then what you're going to do is that you know that the y is equal to x plus 5. If you substituting into the y in the second equation, okay, you are going to get x plus 5. Okay, that's basically y in the second equation minus 2x equals to 2. Okay, second choice. Now let's go over to the next one. So what is the first step to solve for the substitution? Okay, so it's kind of hard to say which one is the first step. Okay, let's see. So the one that you want to use is to avoid fractions. I didn't read the whole thing. Sorry about that. So you don't want any fractions in there. So look at the one that doesn't have coefficient. Okay, so let me put this 3x plus y equals to 9. So if you subtract 3x on both sides, you can isolate the y, and none of the terms has any fractions. So it's going to be negative 3x plus 9. See? No fraction. Okay, so you want to solve for y in the first equation. All right, so what is the value of x when you solve for it? Okay, so this is the one that's good that if you use substitution, because this y's are isolated. Okay, so you can just set the you can substitute in x minus 4 into this y. So you have x minus 4 equals to 3x plus 2. Okay, so this is what I'm going to do. I'm going to subtract x on both sides. I'm going to pick the best color, subtract 2 on both sides, and then I'm going to cancel out, and this is cancel out. So I got 2x over here, I got negative 6 over there. Now you can just divide it by 2 on both sides, so you get x equals to negative 3. All right, so let's move on. Got a couple more to do. So what is the solution to the following system of equations? All right, so go ahead and do what you gotta do. So this is the one that's best if you use substitutions, because we already know that this y is isolated and it's equal to 6x minus 11. Okay, substituting into the second y, so now this is what you're gonna get. Okay, and then we rewrite everything else except the letter y. I'm gonna put 6x minus 11 in there. Okay, now I'm gonna do distribution. So this is negative 3, about to distribute to 6x to negative 11. Okay, so negative 2x. Now it's going to be negative 18x, positive 33 equals to negative 7. All right, so let's combine the like terms. So I'll be negative 20x plus 33. Okay, you know what? That just saves some space. So let me subtract 33 on both sides. Cancel that out. So I got negative 20x equals to negative 40. So now you can just divide it by negative 20 on both sides. Isn't that a beauty? You got x equals to positive 2. Here we go. All right, so let's look at the next one. Which statement describes the system of equations? For this one, you're going to go ahead and solve it. So what we can do is we can see what I can do. Isolate this x, okay? Use a different color. So we got x minus 2y equals to 4, okay? So I'm going to add 2y on both sides. Okay, I got x equals to 2y plus 4. Now, the x is isolated. X is equal to this expression. So you can plug this into the x in the first equation. Okay, so what's going to happen is, let me rewrite the first equation without the x. Okay, you're basically just going to solve this one. So plug this in, 2y minus, plus 4. Now we're going to distribute the 5. So that's going to be 10y plus 20 minus 3y equals to 34. Okay. All right, so you're going to just combine the like terms. So you can combine 10y and negative 3y, so that's going to be 7y. And then I'm going to subtract 20 on both sides. Oh, nice. Hell yeah. So that's going to be 14. So y is equal to 2. Okay, so y equals to 2. Look at this. We're over there. Check that one. Move on. All right, so Mira is playing a game, blah, 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 blah. Okay, so now I just want to point out the X represents the large basket. Okay, because that's exactly what they're asking, right? They're asking how many large basket did she make. So we're going to solve for X. Okay, easy. Look at this equations right there. Just go ahead and do it. Okay, solve for X. So this time X plus Y equals to 15. And the second equation, I'm going to write it over here. 2x plus 3y equals to 35. You might be wondering why I'm putting the equation not aligned, right? Because this is what I'm going to do. I'm going to eliminate the y's, okay? So I can just solve for x. So I'm going to use elimination method. So I'm going to multiply by 3. Okay, I'm going to rewrite this equation as 3x plus 3y equals to 45. Okay, you see that these coefficients are the same with the same signs. So which means that you can subtract one to the other. You can cancel the 3y's out. Okay, so you're going to get x equals to 10. Move on. All right, so a package A contains 3 birthday cards. So we're trying to solve for the birthday cards. And you look at this, 3 birthday cards, and that's the 3x. So birthday cards are basically x. So solve for x. Okay? So now I'm going to rewrite the equation. We're going to solve for x. Okay, so let me write that again. Solve for x. So 3x plus 2y equals to 9.6. 8x plus 6y equals to 26.6. Okay, so what you're going to do is I'm going to use the elimination method one more time. So I'm going to multiply by 3. I'm going to write this on the bottom. So it's going to be 9x plus 6y equals to, 9.6 times 3. It's going to be 28.8. Okay, so that's, wrong color. Okay, subtract one to the other. So the 6y's are canceling out. So we have 8x to subtract 9x. That's going to be negative x. And then 28.8 to subtract 26.6 subtract 28.8. That's going to be negative 2.2. Okay, so the 2 negatives makes the positive, so it's going to be 2.2. Choose a 2.2. Okay, so that's it for this lesson. This is the last one. I don't have a goodbye slide on this one. Sorry. I forgot. Peace.